This video discusses functions. A function in programming is a group of statements that exist within a program for the purpose of performing a specific task. Most programs perform tasks that are large enough to be broken down into several subtasks. For this reason, programmers usually break down their programs into small, manageable pieces known as functions. A function, again, is a group of statements that will exist within a program for the purpose of performing that task. So instead of writing a large program as one long sequence of statements, which could be thousands of statements, it can be written as several small functions, each one performing a specific task. These small functions can then be executed in the desired order to perform the overall task. And of course, in our textbook, it talks about that, Gaddis 2023. Other names used to identify the concept of functions include, but not limited to, subtasks, subprograms, routines, subroutines, procedures, modules, and there's another one that you'll see, especially when you're using certain application programs like Excel. You'll see the word macro. And in object-oriented programming, or OOPS, it may be called a method, but they are all referring to the same concept. Breaking a large task down into some smaller tasks is called the divide and conquer approach, because a large task is then divided into several smaller tasks that are performed. For example, a payroll program in the real world is broken into several tasks, such as the first task would be getting the employee's hourly pay rate, getting the number of hours worked, calculating the employee's gross pay, calculating the overtime pay, calculating withholdings for the taxes and benefits, calculating the net pay, printing the paycheck. So it's going to be broken up into these different tasks. And then we can visually represent these tasks by using a rectangular box. So the main program for payroll, this would be called the main payroll program. And then we'll break it up into different tasks. They're more manageable. Get the employee's hourly wages, getting the hours, calculating the employee's gross pay, calculating the overtime pay, calculating the withholdings for taxes and benefits, calculating the net pay, printing the paycheck, etc. So each of these rectangles can represent a module of some sort. And usually one task of a large program, that function can be executed in order to perform the overall program task. And again, we talk about the divide and conquer approach. That's what we're referencing. So rather than looking at this whole sequence of thousands of statements, we break them up into smaller, more manageable pieces or modules. Before we give you some specific examples using Python, some of the benefits of modularizing a program with functions are that it makes it easier to code, simpler coding. The code can be reused. If I create one function, I may have to use it 10 times in a particular program, but I will have it stored one place, and then I would reference it whenever I needed to use that. We can write the code once and call it multiple times, that is. Better testing and debugging when you create functions. We can test and debug each function individually. Faster development, easier facilitation of teamwork. Different team members can write different functions, and then we put them all together as a team. We're going to first show you how to create a void function, and then we're going to show you how to create value returning functions. There are built-in value returning functions that we've used in the past: input, int, float, are just some of the few functions that we have actually used in Python. These are built-in functions. So before we introduce the examples, functions are given names, and these function names follow pretty much the same rules as variable names. We cannot use keywords as a function name. So in other words, int is a keyword, so we can't use that. We can't use print or float or input, etc. Function names cannot have spaces. First characters must be a letter or underscore. All other characters must be a letter, number, or an underscore. Uppercase and lowercase characters are distinct. In other words, function names are case sensitive. So if you start off with lowercase and put uppercase in that function name, that's how you're going to reference it. Function names should be descriptive of the task that you're carrying out by that function. Often you'll find that it includes an action word or a verb. So when you define a function, in the header you're going to use this predefined word called def. It's going to show up as an amber color. Let me see if I can find an amber color for us real quick. It'll show up as some orange color. I'll just boldface it. And then followed by the function name. That's the name should be meaningful, and it should be some sort of action word. And most of the times what you're going to find is it'll show up in a particular color, and the default color that you'll find it in would be, it'll be a blue, almost like a periwinkle blue. And I'm just going to do this. Make sure it'll show up as a blue color. Followed by open parentheses, close parentheses, and then you'll see the colon. Of course, because this is a control construction, as soon as I press that colon and press the enter key, all the statements associated with that function will be indented. And I always like to, at the end, go back and indicate where that function begins and where it ends with the name. And I may say in and whatever that function name is. That helps you to understand how the program is executing and how you may navigate through the program yourself. Once you define that function, you need to call that function or reference it. As I said, the function header, the first line of the function includes the keyword def and the function name followed by that parentheses and a colon. And then a block of statements that are associated with that function are going to be grouped together and they will be indented. Next, that function has to be called. We call a function so that it can be implemented or executed. When a function is called, the interpreter or compiler jumps to the function and executes the statements in the block. The interpreter then jumps back to the part of the program that called the function, known as the function return. Now, what's going to happen next is we're going to first create a main function, and then we're going to call that main function. And that main function will call all the other functions when they're needed. It defines the mainline logic of the program, so to speak. So what's going to happen is we're going to create a main program to read from an external file and write to the external file. And there will be a specific function that's dedicated to reading the file and then writing the information to that file. So in the next video, we're going to show you step by step how to do this in Python.